At some point in your career, you'll hear someone say, we need to break this monolith into microservices. But what does that actually mean? And should you really do it? In this video, I'll walk you through the evolution of software architecture from monolithic systems to service-oriented architecture, and then to microservices. We'll look at how each one works, the trade-offs, and when each approach actually makes sense. A monolithic architecture is a design where the entire application lives in a single code base and usually connects to the same database. Almost every developer has worked with a monolith at some point. In fact, when we first learn programming at school or university, we are often taught to build monolithic applications because they're simple and easy to understand. Imagine an e-commerce application. It has features for user accounts, product listings, orders, and payments. In a monolithic setup, all of these features are built together in one code base, and the whole team works on that same code base. Monolith works really well in the early stages. They're great for small projects and beginners. Development is straightforward with no complex infrastructure. Deployment is simple because there's only one application to deploy. Internal communication is fast. Sync modules call each other directly without network requests. Debugging and testing are easier because everything runs in one place. But problems start to appear as the application grows. More developers working on one code base increases merge conflicts and coordination issues. You can't scale individual features, you have to scale the entire application. Even a small change requires rebuilding and redeploying the whole app. You're usually limited to one main language or framework. Changing technology later becomes risky and expensive because it affects the entire system. In the early 2000s, companies like Amazon started to hit these limits of scale. They needed a system that could grow faster and change more safely, and this pushed architects toward making application features more independent. And this led to service-oriented architecture, or SOA. In SOA, an application is split into multiple services with each service responsible for a specific business function. These services are meant to be logically independent. They often develop separately, sometimes even by different teams. In practice, services might live in separate repositories or the same one, but the key idea is that their business logic is separated. Instead of services talking directly to each other, communication usually goes through a central component called an enterprise service bus, or ESB. The ESB handles routing, transformation, and communication using standards like SOAP and XML. The main goal of SOA was to allow different systems, including external applications, to reuse and interact with services in a standardized way. The advantages of SOA are services can be developed more independently than in a monolith. Centralized control through the ESB allows for consistent governance and monitoring. The disadvantages of SOA are the ESB becomes a single point of failure. If it goes down, everything is affected. SOAP and XML are heavy and complex, making systems harder to build and maintain. And because of this complexity, SOA today mostly found in older enterprise or legacy systems. And to address this issue, a newer approach emerged, microservices. Microservices build on the core idea of SOA, splitting an application into services, but with some important differences. In a microservices architecture, each service owns its own database. Services communicate over lightweight protocols like REST API, gRPC, or message queues. There is no centralized ESB. Instead, systems use tools like API gateways, service discovery, and observability platforms. Services are small, focused, and designed around a single responsibility. In SOA, an order management service might handle cards, orders, payments, and invoices. In microservices, they are split into separate services: a card service, order service, payment service, and invoice service. The advantages of microservices are services are fully independent, so you can scale or deploy them without affecting others. Failures are isolated. One service going down doesn't crash the entire system. Large systems become easier to evolve because each service has a clear responsibility. Development can move much faster when combined with DevOps and CI/CD practices. The trade-offs of microservices. Microservices are powerful, but they come with real costs. Infrastructure becomes much more complex with orchestration, monitoring, and logging. Debugging is harder because logs and failures are distributed across services. Teams need strong standards and discipline, or the system quickly becomes chaotic. With many services, ownership and coordination between teams can become challenging. And this brings us back to the questions from the beginning. Should you break your monolith into microservices? The answer depends on your team size, your system complexity, and your real scaling needs. So monolith, SOA, microservices all exist for a reason. Understanding the trade-offs helps you make better architectural decisions.